When routing piping throughout a facility, there are instances where we must establish its position relative to non-piping elements. These elements typically include buildings, structural components, pipe supports, pipe racks, or modular units. To achieve accurate placement, a reference dimension can be incorporated into the model. This ensures precise alignment with non-visible components. In this lesson, we will explore how to define a reference dimension in isometric drawings, aligning piping with structural steel elements. To begin, open Chapter 10 in the Plant 3D drawings and access the file 10_model. Observing the grid reference, we can see columns labeled A1 and A2. The objective is to position the center of a flange in relation to the center of a column. The same process will be repeated on the opposite side, aligning another flange accordingly. First, switch to wireframe mode to visualize the centerlines of the structural columns. Next, navigate to the Reference Dimension tool and follow the prompts displayed in the command line. The initial step involves selecting an insertion point on the piping component, specifically the center of the flange. Ensure object snaps are activated for accuracy. Then, identify the reference point by selecting the midpoint of the corresponding structural steel component. Once the reference dimension is established, a dimension annotation will appear, displaying the measured distance. This will indicate, for example, that the piping is positioned at a specific offset from the structural column. Adjustments can be made by selecting the dimension and modifying its properties. Within the Properties panel, the type of referenced object can be specified. In this case, select Steel Column. The enclosed message format can also be adjusted, such as using a circular label. To identify the column reference, input the corresponding designation, such as A2. Next, repeat the process for the second flange on the opposite side. Again, use the Reference Dimension tool to align it with the appropriate structural element. Select the midpoint of the steel beam for accuracy. In the Properties panel, assign the reference label, such as A1. With reference points in place, adjustments can be made as needed by selecting and modifying the annotations. Now, let's proceed to generate isometric drawings incorporating these reference dimensions. To avoid unnecessary complexity, filter the selected piping lines to include only those of interest. In this example, choose line numbers 400 and 300. Use the Quick ISO function to extract isometric drawings without excessive clutter. Adjust congestion settings as needed and generate the drawings. Upon review, the isometric drawings should accurately reflect the flange locations in relation to the structural columns. Even if the annotations appear slightly misaligned in the model, they will be correctly represented in the isometric output. These drawings will clearly denote the column reference, offset distances, and critical alignment details. Although isometric drawings typically function as standalone guides for pipe fabrication, there are situations where additional reference information is necessary. By incorporating precise reference dimensions, construction crews can accurately position piping components in the field. This ensures proper alignment with structural elements, especially when dimensional accuracy is crucial. Providing these references within isometric drawings is an effective way to convey essential information to construction teams, aiding in the seamless execution of installation tasks.